Tap a glowing button on your phone, and by the next afternoon, a cardboard box is sitting on your front porch. It is easy to picture Amazon as one gigantic supercomputer, humming in a massive basement somewhere, handling every single search and purchase. But behind the screen, it functions like an invisible superstore. Instead of one giant machine doing everything, Amazon relies on thousands of tiny, specialized digital workers, all coordinating in perfect rhythm. In software design, this is called a microservices architecture. Think of it as breaking down a massive company into entirely independent departments. If millions of people tried to crowd around one giant computer at the same time, the whole system would freeze. By splitting the workload among independent teams, millions of customers can shop simultaneously without the storefront ever slowing down. So let's walk up to the front doors of this invisible superstore. The very first worker you meet is the API gateway. You can think of them as a strict security guard. They check your digital ID, turn away malicious bots, and politely point you toward the correct aisle. Right next to the security guard is a helpful greeter known as the cache. This is a temporary memory system holding the exact items you looked at yesterday, presenting them instantly so you do not have to go searching from scratch. Before you have even typed a single word into the search bar, these front door systems have secured your connection and predicted your needs, keeping everything incredibly fast and safe. Once you are inside, you might want to find something specific, like a new pair of headphones. But finding one item hidden among millions of products presents a massive math problem. If a worker had to physically run down every aisle to check boxes one by one, you would wait hours. Instead, engineers use a search index, like a store clerk holding a magical clipboard that perfectly tracks the location of every single item. Specialized search software splits your request into thousands of parallel searches across an indexed grid, filtering millions of items in milliseconds. Without this index sorting massive data blocks ahead of time, checking the primary database for every search would cause the system to time out. You find your headphones and click Buy Now. You have reached the checkout counter, handing your order to a worker called the order service. In a physical store, the cashier takes your cash, runs to the back room to pack your item, and leaves everyone else in line waiting while they finish the job. This split-screen diagram compares traditional setups with asynchronous processing. Instead of a continuous loop blocking the line, incoming tasks are separated. Our digital cashier prints a ticket, tosses it onto a background conveyor belt, and instantly yells, "Next customer." That ticket triggers several background workers to spring into action at exactly the same time. One verifies your credit card, another checks the local warehouse stock, and a third sends an email. Because these tasks happen in the background, the screen tells you the order is complete right away. Disconnecting the checkout button from the background tasks allows millions of customers to move through the line without a single delay. Now let's step behind the counter and into the back room, where Amazon stores all the raw information needed to run the platform. Different data requires different systems. For users, the system uses a SQL database. This creates perfectly organized rows and columns, where the rules for entry are incredibly strict. But products and orders require a completely different approach. For millions of varied items, engineers use NoSQL databases. These act as flexible storage, where different types of data can be pulled quickly without rigid formatting rules. And for the fastest possible access, temporary data, like the shopping cart, is stored in a Redis cache. Matching the exact type of database to the specific job is what keeps the entire operation stable. This all works smoothly for one shopper, but on days like Prime Day, millions of people flood the invisible superstore at the exact same second. So how does the system absorb a massive sudden spike in traffic without collapsing? This diagram shows a load balancer. It monitors the incoming line, directing the massive surge evenly across identical servers. If an area gets too crowded, it instantly clones our digital workers, spawning new cashiers and security guards in real time, so no single server gets overwhelmed. Once the digital checkout clears, the physical process takes over. Because Amazon duplicates its digital inventory catalog in data centers all over the world, your order is instantly handed to the warehouse physically closest to you, cutting shipping time down to hours. A package arriving on your porch the next afternoon is the result of thousands of independent digital workers coordinating with trucks and warehouses. It is a perfectly choreographed relay race. In our next episode, we will look at how Twitter, or X, handles millions of live updates in a real-time system. Follow along to master system design step by step.